Hello everyone, in this video we'll be talking about fast exponentiation. As you can guess from the name, it's a way of taking exponents fast. So what do I mean by that? Take for example 256 to the power 128. Now in general, we think of this as like 256 times 256 and taking this multiplication like 128 times. But we can do better. We can do 256 square times 256 square like that, and then we'll be doing the same multiplication in just 64 steps. And we can do even better. We can do 256 square times 256 square like that, and then we'll be doing the same multiplication in just 32 steps. So what is the most efficient way here? If you do 256 square square, so that's 1 2 3 4 5 6 7, because 2 to the power 7 is 128. So here we are doing the same multiplication that before took us 128 steps. Now we're doing it just 7 steps. But this is not exactly fast exponentiation. To see how to do fast exponentiation, we first need to know how to convert a number from one base to another. What do I mean by that? The number system we use is called base 10. Why base 10? Because we express all our numbers using digits from 0 to 9. Now if we take example a number with like number system with base 6, that will express all of its numbers using digits from 0 to 5. Now for fast exponentiation, we just need to know how to convert a number from base 10 to base 2. We just uses digits 0 and 1, but the process of converting from like base 10 to base 6 and base 10 to base 2 is essentially the same. So first I will show how to convert from base 10 to base 6, and then I'll show how to convert from base 10 to base 2. So for example, now I want to convert 125 to base 6. What will be that? So divide 125 by 6, so that's 20 with a remainder 5. Now divide in 20 by 6, that is 3 with a remainder 2, and then divide this by 6, that's 0 with a remainder 3. Now here we call 3 the most significant bit and 5 the least significant. Why? We'll come back to that later. Now 125 in base 6 is then 325. Now to check if this is right, what we can do is 3 times 6 square plus 2 times 6 to the power 1 plus 5 times 6 to the power 0, and see if this adds up to 125. And if we do that on calculator, yeah, it adds up to 125. Now if you look here, 3 has the highest weight, which is 6 square. If you go to 2, it decreases, it's 6 to the 1, and 5 has the lowest. That's why 3 is the most significant bit and 5 is the least. Now how do you convert 125 to binary? We can do the same way. So 125 divided by 2, that's 62 with the remainder 1. Now we can divide this again by 2, that will be 31 with the remainder 0. Then by 2, that's 15 with the remainder 1. Again by 2, that's 7 with the remainder 1. Now 7, this is by 2, this will be 3 with the remainder 1. And by 2, this is 1 with the remainder 1. And then 2, this is 0 with the remainder 1. So then 125 in base 2 is 1 1 1, because we go from low to up. And remember here I've just repeated, so don't count this one and this one twice. Remember that. So this is 1 2 3 4 5, so 5 1s 0 1. That's how we write 125 into binary. But instead of doing all this division, we can do this in sort of a shortcut way. For this, think of putting a number into buckets. What do you mean by that? So to express 125 into binary again, And remember, this only applies to binary, not other. Like, you cannot convert 125 to base 6 using this way. It only applies for binary. Now, take for example here, we go from left, from right to left. So 2 to the power 0, 1, 2 squared, 2 cubed. I'll just start writing into numbers. 16, 32, 64, 128. Now, think of putting 125, think of dividing 125 into these numbers. What do I mean by that? So 128 is greater than 125. So I can put this here. So this will be 0. Now, 125 is definitely 64 is definitely less than 125. So we can put here. And then 64 plus 32, that's 96, which is less than 125. So we can definitely put a 1 here. 96 plus 16, that's 112, which is less than 125. So I've put a 1 here. Then 112 plus 8 is 120, which is less than 125. So you can put a 1 here. Now 120 plus 124, that's still less, 1. Now this will be a 0 because 124 plus 2 is 126, which is less than this one. So this is around finally, yeah, this will be 1 because 124 plus 1, 125. So here, in a lot less steps, we have converted 125 into its binary. Now, why do we actually need to convert a number from one base to another? Think of the YouTube URL. At the end of the URL, you will see something like AB36, blah blah blah, other numbers, which is they're 11 characters. Now, here, YouTube actually uses a 64 base number system. And using 64 base number system on just 11 characters, in this 11 characters, YouTube is able to pack decimal equivalent of 73 quintillion video IDs. See, in just 11 characters. So that's why going to higher bases makes the numbers more compact. But also, there's another reason, and which is security reasons. So for example, if YouTube used a decimal way slash 124, then you could just go change this to 125 and see what's the next video and the next video. But that would break the security because there are a lot of videos in YouTube which are unlisted. And now if you could just scramble through all the videos, then you will be also able to see the unlisted ones which you are not supposed to see without having the link. That's why when they're using this way, it's ensuring more security. Just so you know, the highest base number is actually 65,536, which includes all the characters, includes all characters from all languages. Now that's enough outside stuff. Let's get into how to do fast exponentiation now. So to do fast exponentiation, we will take 1819 to the power 13 mod 2537. Now, so that I don't have to write these numbers again and again, I'll just take m equals to 1819, n equals to 2537. Now first, for fast exponentiation, we need to convert 13 to its binary. So if you think of that, that will be 1, 2, 4, 8. Now if you put 13, so this will be 1, 1. 8 plus 4 is 12, so this will be a 0, this will be a 1. So this is the binary representation of 13. Now, to solve this seemingly impossible thing, first we'll take m to the power 0 equals 1. Now, we will do m to the power m1, take the first, we'll go from left to right. So we take the first one here. M to the power 1 mod n. Now for this, what we do, we take 1 square times m. 1819 mod n. So that's just, you don't need even a calculator for this. 1819. Now, what's next? Then we'll take the next one. So this will be m11 mod n Now, like that, we'll take the square of the previous number. So here's 1819. Now, as there is a 1 here, we will multiply it by m again. I know this might sound a bit confusing at first, but like after you do like the next or like the last step, this will become clear. So this mod n, if you did the calculation, this will give you 2068. Now I'm taking m110 mod n. Now here, this time this is a 0. So we just take 2068 square. So we don't multiply by 1819 this time. So 2 square mod n, and if we do the calculation, this will be 1779. Now finally, m1101, the last one, mod n. So here we again have a 1, so at first, like as usual, we'll do the square times for the 1. This will multiply by m mod n, and this will give you 2081. Now to recap what we just did here. First, you convert the exponent to its binary, and then we start from m to the power 0 equals 1. You go from left to right, and when there is a 0, you multiply, like you take the square of the previous number and then mod n, which is like this number. But when there's a 1, you obviously take the square of the previous number, but you also multiply it with m and then mod n. So that's how. Now why do we do this? It's because like in real life, when computers does this, it's not 13. This will be like a, this is like, I don't know, like a huge number. For the huge number, for the computer, if it does it this way, it can do the calculation a lot faster than just taking the multiplication, like, I don't know, like maybe 1000 times. It's like the motivating example that I show like at the very beginning of the video, that like if you take square and square square, you do it in a more efficient way. We're essentially doing the same thing here. So yeah, that's why fast exponentiation is important, and computer sees this. And yeah, that's all for this video. Thank you.